Walk into a top-tier AI lab today, and the actual day-to-day work looks very different than it did just a couple of years ago. The engineers aren't typing out thousands of lines of code. Instead, they are acting as managers, handing high-level goals to autonomous AI agents that run the code themselves. In Anthropic's own production codebase, over 80% of the code currently merged is authored entirely by their AI model, Claude. Because the AI is drafting, human output has skyrocketed. The typical engineer now ships 8 times as much code as in 2024. For thousands of years, a new tool might make human labor faster or easier, but the humans still had to swing the hammer. Now, the physical execution of the work, the actual typing, testing, and formatting, requires almost zero human time. The system is drafting its own architecture. The majority of the labor pushing artificial intelligence forward is now being performed by the artificial intelligence itself. By any conventional business metric, this automated workflow is a total operational success. The company is operating at a massive multiple of its human headcount. Yet, at the exact moment their system is generating this incredible speed, Anthropic's creators are explicitly publishing a roadmap detailing how the entire globe must unite to halt it. This chart shows a theoretical cycle known as recursive self-improvement. It is a closed loop where an AI system generates code, reviews its work for errors, runs experiments to test it, and then uses those results to make itself smarter. That first step, generation, is already heavily automated. As we saw, the models are now drafting the overwhelming bulk of their own codebase. The review step is falling quickly too. Automated AI reviewers are now scanning the code and consistently catching underlying security flaws and bugs that the world's best human engineers overlook. And the models are moving through the experimental research leaps, testing optimizations over and over to find speedups, up to 52 times faster than standard baseline code. The mechanical execution of building an AI model is effectively solved. The only major bottleneck holding the system back from operating entirely on its own is the human capacity for research taste, the judgment to decide which experiments are actually worth running in the first place. A common counterargument is that a machine can run 1,000,000 tests, but it takes human intuition to look at a dead end and decide what broader problem to investigate next. To test this, Anthropic researchers isolated specific moments during their own complex investigations where a human engineer pursued a direction that eventually led to a dead end. They paused the session right before the human made that mistake, handed the same data to the AI, and asked it what it would do. In those highly ambiguous situations, the model suggested a better next step than the human expert 64% of the time. That means research taste is increasingly something the model can execute. The final human constraint preventing a fully closed autonomous development cycle is collapsing. Anthropic outlines a highly probable third scenario, the point where models become fully autonomous and their advancement uncouples completely from human brainpower. In that state, the only things dictating the speed of AI progress are physical inputs, how much electricity the grid can supply, and how many server racks the models can access. When a system loops and improves itself at the speed of computation, any minor flaw in the model's goals carries over. With each machine-generated iteration, those rare misalignments compound, growing more frequent and less understood by the humans locked outside the cycle. A system capable of out-innovating its creators will naturally outgrow their oversight. It represents a threshold where we lose the ability to control the behavior of our own software. If a self-improving system poses this risk, the straightforward solution is for the leading labs to simply hit the brakes and pause development. This diagram illustrates the geopolitical trap preventing a pause. If one cautious lab voluntarily stops, the competitive incentive to defect is massive. A rival corporation or nation will quietly use their own AI agents to keep working, and because the cycle moves so fast, they secure an insurmountable lead. Unlike traditional arms control, where spy satellites can easily spot a physical missile silo, a massive digital training run uses general-purpose computers. It is almost impossible to track from the outside. This is why Anthropic is pushing for a global, highly resourced verification system. The only way to safely stop development is through an international treaty that guarantees every lab at the frontier pauses simultaneously, with mathematical proof that no one is cheating. The immediate challenge isn't the engineering hurdles of superintelligence. The challenge is building a global diplomatic brake pedal before the machine finishes building itself.